Okay. Good afternoon, everybody. I'm Kieran Dines, VP of Products at Talent, and joined by Cedric Carbone, CTO. Today we're going to talk to you a bit about what Talent do. We're going to show you a demo of the software. We're kind of a last-minute substitute replacement for the previous speaker. Very happy to be here and show you what we do. For the demo, we've taken something that Hortonworks have done. So if you go to the Hortonworks website, they have a lot of different tutorials which help people get started with MapReduce, Pig, Hive, whatever it may be. So we specifically took one of their demos, which is the Clickstream demo. So if you're familiar with it, what we're going to show you is what things look like in code, and then how you would use Talent to basically do the same thing. Now, rather than basically this being a complete publicity stunt on behalf of Talent, we'd actually like you to talk a bit more about the internal workings of what we actually do in terms of the code generation, and talk a bit more about the performance implications of code generation and some of the independent benchmarking that we've been doing. So Cedric's going to take us through the demo. He's obviously my technical aide to talk through a lot of the benchmarking work that R&D has been doing. But I'll talk over the slides and talk a little bit more about what we're showing. So first thing is we're going to talk about the Clickstream Live demo and moving from hand coding to code generation and the implications for doing that. We're also going to talk about performance benchmarking and optimizations that we see that we can do as part of the code generation. But obviously we're working very, very closely with Hortonworks and Owen O'Malley and a bunch of other different people to basically figure out what optimizations are coming in Hive, what optimizations are coming as part of the Stinger project. And because the way Talent works, we're very much just built on top of the Apache API. We then basically derive those benefits as well, because any performance that goes into Hive, then it directly impacts the way we do the code generation. All right, so this is the Hortonworks Clickstream demo. It kind of looks like this. If you're familiar with it, I mean, the green bit's the Hortonworks bit. We load a bunch of what's called Omniture log files. So Clickstream data, it could be Apache log files, it could be anything. Omniture basically is a company that provides analytics on top of Clickstream and web data. That gets ingested into the Hadoop Hortonworks platform. There's a bunch of refinement that happens in there, basically doing a number of MapReduce jobs. You could do it with Pig, you could do it with Hive, you could do it with whatever you wish. And then at the end, obviously, it's an analytics demonstration here. So you can visualize this with Excel, which is the way Hortonworks does it in their tutorial. We've also done it ourselves with Tableau. You can do it with other types of visualization tools. Today, we've actually built an application with Google Charts. So basically just using Google's JavaScript, we basically have built up a simple web application. So you can imagine basically taking this and automating this entire process. Continuously streaming in data from the Clickstream, pushing into Hadoop, doing some refinement, and then those stats and pieces of information become accessible to some particular audience. So a little bit more in terms of what we do. We kind of get away from this, which is doing stuff by hand, and move it to this, which is a visual representation inside Eclipse. So it's very much an Eclipse drag and drop metaphor. What you can see here is something that we recently added, which Cedric is going to take you through in a lot more detail, where you see these green boxes and the red and the white boxes. That's actually MapReduce running live inside Eclipse, and we're basically getting back statistics from the MapReduce job. So percentage completed, how much is left to go, that type of thing. So statistically, you start getting information directly back inside Studio. And what's interesting is, depending on how you design the MapReduce job, we will indicate to you how many mappers, how many reduces are actually used for that particular application and flow that you've developed. So when we go on and talk about the benchmarks, this has huge implications in terms of how you can optimize the way you basically build a MapReduce job. All right, so quickly on the demo, what we do, as I mentioned, we show how to load in the raw Clickstream data. From there, we basically build a number of MapReduce jobs that we run inside the tool itself. All the results are written back into HDFS. And then lastly, we show you some examples of analytics tools. So it's a pretty straightforward use case. It's exactly what Hortonworks does in the tutorial. We've just taken it and redone this inside Talent Studio. So again, it looks like this. Talent basically has taken this. We load the data using Talent into HDFS. We do some internal MapReduce processing, which we will show you. And there's a number of different types of jobs. So we do things like aggregation, we parse the data, we combine customer records with other types of information. So it's basically a cleansing activity we're doing here to get the data in the right format, such that when it goes back into Hive, once it's in Hive, clearly any types of analytics tools that support that, you can do many different things with it. And the demo we'll show you today, I think we'll show you certainly the Google Charts piece, and if we get to it, we'll quickly show you what happens in Excel. So it's all very, very straightforward. All right, Cedric, do you want to talk a little bit about what we actually do under the covers in terms of Studio?
Yeah, sure. So first, we are based on Eclipse, as said, and we generate pure native code, Hadoop code. So that means, in fact, you don't need to know MapReduce. We will generate this for you, and you don't need also. So to have the knowledge of MapReduce, you don't need to install something on your cluster. So it's something very important. You have a lot of products that need an engine on your nodes. So that means every time you will add a new node on your cluster, you will need to install also the engine. And if the engine is down, that means this node, you cannot use it anymore. At Talend, in fact, we say that the engine is Hadoop. So that means if the Hadoop node is running, you can use it because we will just give to this node a native code.
Yeah, so ultimately, as Mike Gutierrez said this morning, Hadoop is the engine for data processing for the next decade, let's just say. So it is this data operating system that he talked about. And the way we do the code generation, it is 100% based on the Apache API. It's not some intermediary thing. So again, if Owen O'Malley or all the great guys at Hortonworks or at Cloudera or anywhere else, whatever contributions they're making to the community, we directly get those performance benefits back into the way the code is integrated. All right, so Cedric, do you want to take us quickly through the demo? So if you can switch over the screens, I'll stand out of the way a bit, and then Cedric can show you. This is Studio.
Sure. So here is the Eclipse Studio. So the first stuff I will did is put my log files on my cluster. So here with this component, I will be able to put some file, so all of these files, tabular separated value files, to this HDFS path. So as it's a real demo, I will just show you that the user Talend here, so on HDFS, there is no Clickstream folder, and I will run this job to create it and to directly upload these files. So here you go. I will refresh the file browser. And now you see Clickstream demo, input, and several files I will need for this demo. So the first file is in fact all the logs. So it's quite complex to read, but this is a web log when you can see IP address here, for example, where you can see, we'll do some lookups, is it user ID? Is it some URL that in fact is product? So we'll also do lookup to transform this URL to real product categories. And in fact, we'll parse all these files to have something more readable. So, sorry. My file is now on HDFS, so I will do some processing. For that, I will use pure MapReduce code generation. So I will do a first job. So a job in Talend is a process. So when I spoke about job, sometimes it's MapReduce job and sometimes it's Talend job. So all this stuff, we call this a job. So here, what I will do first, I will read the file on HDFS. So you can see I will read this file. So you see, in fact, a lot of context.something. We have a context management just to be able, in fact, to change some variable, like file path, for example. It's not the same when you are on QA server or on production server. So we have a context management. that define for each variable, for example, in instance, Hadoop user that define its talent. And I will use this variable on my component just to be able to have something flexible. So here I will read this file, so I can also preview it on my studio. So and I will see it on a more, let's say, human readable way. So here is my file with a lot of columns, more than 100 columns, and you will get, for example, there is a lot of columns. So you will get the product categories I spoke about, or the user ID I spoke also about previously, or IP address or other stuff. IP address here, for example. So I will parse this data, and I will enrich them with some other information. So I have another file with a product file. So in this file, I will just preview it, and I load it on the first step. I load several files. And this one is a very simple file with to do a lookup. So with an URL and categories. For example, this URL is electronics categories. This URL is computer categories. So I want to do my lookup. So I have, in fact, these two columns that come to my tmap. So it's my mapper. So here I will see all my input file with my 100 of columns and my product file with my lookup. And I will just indicate that the column 12 is the URL. So I won't do the lookup with this file, and I won't take the categories. And on output, I don't want my 100 of columns. I just want my log date, IP, URL, the user ID, city, country, state, and categories. And I want also manage reject. If I cannot do the lookup, the inner join here, if I cannot do this lookup, I want to create another file with only the URL that I cannot match. So you will see on the bottom of the job, I will write on HDFS a reject file. After I have another lookup, it's exactly the same stuff with another file. Let me preview it. So it's the user ID I have on my log file with a gender, male, female, or undefined, and a date of birth.
So Cedric, just comment briefly, if you can, on the type. So this is text, but what other types do we support?
Yeah, so we support quite a lot of format on Hadoop. So if you have Avro, for example, we have some specific component to have Avro. We support quite a lot of format, and we will continue to support more. For example, we have on the roadmap to support Parquet. We don't support it in our GA right now. It's only on our labs, and we will add this on the next release. So the lookup for user is exactly the same. So my input file is as this column. I have my ID, my user ID, and I will just drag and drop to get date of birth and the gender. And I will do some calculation here. For example, for the gender, if it's null, I won't. For the gender, I will just calculate the age. So in fact, you can also inject some code. Let me just come back on this. It's quite important. In fact, we generate pure MapReduce. In fact, we generate Java. So if you know Java, you can also inject Java at any time. So for people that don't know Java well, we have some library that will say, okay, I want to do an upcase, so I will go to string handling, and I have some function here that will do an upcase. But if I know Java, I can directly do two uppercase, and it will bring me, let's say, all the functionality Java can provide me. So I can inject Java anytime in Talend. It's not a black box. You can really inject code inside. Okay, and at the end, I should write the result on a folder called result on my HDFS. So it will be, let's go back to user, Talend, Clickstream. So here I will have output and result. So let me run the job. So as Kirian mentioned, we have some real-time statistics that will appear on my screen. So here we go. So we will start the job. So it uses a sandbox. So it's only one node running on my small box. So it will take 1 or 2 minutes to run. But if you have a rail cluster with you, for sure it will be faster. So you can see here I'm on this operation on map right now. You can see also here some logs, 25% of map. And you will see it will move step by step as a job. So 50% now, etc., etc. And just the time this job is running, let me just take the opportunity to show you some of our components. So for input, for example, you can use Avro, we spoke about that, JSON, HBase, or HDFS, or also GDBC. So it's a native input we support. For processing, right now we do mapping, but you can filter columns, filter data, filter rows. You can convert some type. You can aggregate, do average, do max, mean, count, etc. You can. So here you see it's green. The first MapReduce job, Hadoop MapReduce job, was finalized, and now we are starting a new one through intermediate result we get from the first one. So
I guess one of the big things to note here is that Studio is running, for all intents and purposes, on this laptop. And if you can imagine, there is a cluster somewhere. The cluster is in a virtual machine on the same laptop, but if it was somewhere else, it could be at Amazon, it could be wherever it may be running. Studio is actually completely bundling up the MapReduce job and remotely deploying it. And all the stats that you see on screen are the stats that we're getting back from Hadoop itself. So everything basically is done remotely, and there is no pre-install required.
So for processing, you have filtering, convert, aggregate, replicate, replacement of data, sorting. So we have logs. We have a lot of stuff for data quality, like matching or standardization, deduplication, and you can also inject directly your MapReduce handmade code. So it's finished now. Let me go back here and see if I have an output folder. I should. Clickstream, output. Here you go with result. So I have first intermediate result where I have less columns and where you will find more information like the gender, so female, male, etc., or undefined from the customer. So I enrich the data. And other, what was the second stuff I did? The product categorization, sorry. Here, so you can see it shows or other categories appear on the file. Okay, so now I will do other stuff. I will continue and generate Google chart. So just to see, in fact, this data, but through visualization. So I have another job that will, in fact, take the data from Hadoop, from HDFS. So it's exactly, in fact, the data on my output folder, the result. And I will, in fact, do some processing, and we will see real-time statistics, and generate at the end an HTML file that is a Google chart HTML file. So let me run it. Okay. So here you will see real time, in fact, so all the rows, I do some several KPI, in fact, several aggregation here. And at the end, I generate one HTML file. And the HTML file is, so it's on the context variable, on this folder. So let me see it. So home, talent, document. File browser is long. I think it will come. Okay, it's here. And after it's on Clickstream, and I have an HTML file just created. So let me open it. So here, in fact, you see what we produce with all the data, in fact, but through Google Chart. So you can see the categories, the main categories or top categories, depending the chart you are looking for, and some aggregation, the number of clicks, depending the state and the categories. And I have a last job to show you, is to create the Excel spreadsheet. So I will connect to my Hadoop cluster and take my file, my result file. I will do a filter. I will remove all edges that are empty, and I will create a CSV file. So let's do it. And also what I will do, I will also create a Hive table that is an external table, just to store also the data through Hive and to be able through SQL access to my result. So again, it's pure code generation. So at any time you can go to the code, you can see how we generate the code. You can, for example, let me look for external table. So you can see what is the HiveQL I generate, how I generate it. So it's not a black box at all. And you can also run in debug with a Java debugger, put breakpoint, inspect code, etc., etc. So if you have a Java developer, you can really do what you want. So here I generate a file, and now I have also a Hive table created. So let me see the file first. So the file should be home talent document weblog. So should be weblog.csv. So it's a CSV. Let me open it with Excel. It will be better. Oops. So I have Excel on my host server. Let me drag and drop it outside the VM and open it with Excel. Here you go. So you have all my results with the IP address, the URL of the product, the ID of the user, and the enrichment I put, like the age of the user. Through the ID, I can retrieve the user, I can retrieve the date of birth, and I can calculate the age and the gender, and the category also I retrieve through the URL. And let's go to the VM also just to see Hive, the last stuff I won't show you today. For Hive, I will use U. Okay. Let's go. Just do a select star from from Clickstream. Here you go. So we have the information, but now in Hive, and you can query it through SQL.
Cool, great. Thanks, Cedric. We can switch back to the.
Just one stuff, perhaps. In this demo, I don't show you all the possibility of talent. For example, we can also generate pig. If you want, we generate pig. So for example, here I have another example that will do some aggregation, filtering, etc. So it's always the same stuff. So you have graphical user interface. You say, what is my grouping column? What is my operation? For example, I want to do a sum and average on which input column, which output column. But behind the scene, it will just generate pig Latin script instead of MapReduce or instead of Hive. So we just provide several ways to generate code We have also Maut, Uzi, a lot of support for other Hadoop stuff. Sorry.
Cool. Oh, great. Thanks. Can we switch back to the slides, please? One of the other thing we didn't comment on is that most of this, by the way, is open source. So very much, Talon's DNA is an open source company, and you can basically get the Talon Open Studio for big data from the website. What's more interesting, maybe.
And by the way, sorry, this demo will be also available packaged on our website in a few weeks.
Yep. Yeah, we'll talk about the sandbox. But what's interesting is a little bit more of the science behind this in terms of the performance of the code generation. So since probably early January, we've been looking very closely at the code, particularly the MapReduce and Pig code, to see whether or not we are as performant as we made out to be. So if we're generating code, expectation should be that we are running as fast as somebody could write it by hand. And we've been proving that to ourselves. So, Cedric, do you want to briefly talk about some of the things we're doing, particularly with Yarn, and why that's important to us? But maybe we can just mention Storm and Spark as well.
Yeah, sure. So, in fact, we support Yarn since it's GA. So we released a product on October last year. And we with this product also we support Yarn on HDP. And through Yarn, in fact, you have a lot of way to do processing. It can be batch through MapReduce. It can be streaming through Storm. Or Spark streaming. It can be in memory also with Spark, etc., etc. So, in fact, we support. Currently, we don't support all this stuff. For sure, we support HBase, MapReduce. On our labs, we have Storm and Spark implementation. And by the way, for Spark, we are working with a partner called Altic, with here also. And we support also a lot of NoSQL, like MongoDB or other. But our way, it's really to get some feedback and to continue, in fact, with our partner and with our community user to develop new components. We have more than 800 components, and most of them, in fact, came from the community.
All right, so how does it all fit together? What you've seen today is a bit of the studio. In the background, Hortonworks is clearly running here, and there's also some analytics. Talon is very, very strong on data ingestion. So as Cedric mentions, we have about 800 or so components. So we can take data from anything, data warehouses, databases, whatever it may be, flat files, web services. And we also support things like Scoop and all those types of tools as well. And we generally will push that information into HDFS. That's kind of the first thing that we would do. Data warehouse optimization use cases. Practically every single company we work with in the US, that's what they're doing. And it's not dissimilar with the companies that we work with in Europe. And then when information gets into the Hadoop ecosystem itself and on top of things like Yarn and into Hive, that's kind of where Talon comes into its own. Because we have this native code generation mechanism, we can take our core technology like mapping, transformation, parsing, cleansing, deduping, all of these great things, and we change the underlying code generation. So it's still the same look and feel, but we now generate a different coding language to basically take the benefits, either performance-wise or whatever it may be, from that underlying framework. And then on the outside, basically, we can deliver that technology back out there. So we have a full range of integration software, and we kind of cap, this notion of tap, transform, and deliver in terms of how we work. But what's more interesting is the benchmarking that we've specifically been doing on MapReduce and Pig. Do you want to just quickly run through the overall spec?
So in fact, we just put 9 servers to do a first small benchmark. So we have 18 maps, 18 reducer available on the cluster, and we try several use cases. So you will speak about the use case later. Yep. With several range of data. So 1 giga, 10 giga, or 100 gigabyte.
Okay. Cool. So what we've been also looking at is, can we find an independent benchmark? We have lots of customers obviously giving us different benchmarks, things to try. We're not going to go through those today, but what's more interesting is, can we use an independent benchmark? So we have TPCH. So there's a bunch of guys, I think they were at Berkeley, maybe it's not listed up there, but they took the TPCH framework and they basically hand-coded that in Pig and also in Hive. And what we've been doing is running that on the cluster that Cedric just mentioned, which is this 9-node cluster we have in the labs. And then we're comparing it against two things. We're going to compare it against the Talon Pig-generated code, and get a baseline to see how well we perform there. And then we compare that against our MapReduce jobs. We still have an outstanding task to look at the Hive part of this, but right now, because most of our customers are using the MapReduce and the Pig piece, we really focused our efforts basically on doing that comparison. And I guess we're complimenting ourselves, saying the results are very good, which is great. But maybe we should talk a little bit more about the some of the highlights in terms of configuration.
Yeah, so first, in fact, we follow some Hadoop guidelines. So if you are not aware about that, so there is a link on the wiki where, for example, one rule is to use 99% of the total reducer available to use it, in fact. So there is plenty of other rules. So it's just to highlight one, that you can understand how we work. And for example, so for Talent, so we run it on 3 nodes, 6 nodes, 9 nodes, also to see the linearity of the benchmark. And so that shows for the first one we have 5 reducers, the second one we have 11, and the last one we have 17.
Yeah, and one of the things that we don't highlight in here is to configure. I think it's one of the benefits of Yarn, but to configure any one of the jobs. Depending on the number of mappers and reducers, you will definitely get different behaviors and results. That's clear to us. And through the studio, you can set those properties on the developer side, and then those properties are reused when you deploy that on top of the cluster. So one of the companies that we're working with in the US at the moment has a 700-node cluster who's doing a lot of performance work with us. And what we've been able to demonstrate is that even our 9, the small node cluster, that the results that we get for the use cases they provide to us are directly applicable to what they do on their 700-node cluster. So it's been great in terms of interactivity. We're building the jobs, shipping them over our results, and they're running that in the bigger cluster and validating those for us. So here's the results. Definitely some good, some bad, and things to note that we've taken to heart ourselves. But in general, very, very good. So what you see is this is the 19 results that we have here. In general, we're the same. In some cases, we're not the same. In some cases, we're actually better. Now, that doesn't mean that Talon's a better writing code than the Berkeley guys. It just means the code that we generate is more optimized for that use case. So, it's all open source. You can pull the code easily from Talent, and we could redo the Berkeley framework, the hand-coded framework, and use some of the optimizations. What's good from our perspective is that the code that we're generating basically is as good as the handwritten code, except for there's a couple of use cases in here, and we're going to talk about those in a bit more detail. So we're faster in some cases. We're still trying to figure out why in some of them, so we're doing a lot more analysis just to make sure that the benchmark is 100% accurate, but we're pretty confident on that. But there are performance improvements that we've identified. So the first one is, Cedric, do you want to quickly talk about what is code group and why that's interesting to us with Pig?
Yeah. In fact, it's a function available in Pig that we didn't implement in our code generation. And when we run this use case, in fact, we see that, in fact, our performance are not good at all compared to the AND script, Pig Latin script developed by the Berkeley guys. So through this benchmark, in fact, we can detect also some issue on our way we generate code, and we can after fix it for sure.
Yep. And the second one's very interesting because as I mentioned earlier, the studio has the same representation. So it has this Eclipse drag and drop metaphor, and we have things in there called sort components and filter components and aggregate and map components. But because the code underneath the covers is changed when we generate it for MapReduce versus normal Java, we can actually do things differently. So one of the things we've done is we've implemented the TerraSort algorithm for the Hadoop code generation. And we only use that for the Hadoop generation. It's only applicable there. But Cedric, do you want to talk through some of the other things that we've identified as interesting areas?
So the TerraSort, in fact, has 2 steps, 2 MapReduce jobs. In fact, one, in fact, to define the bucket we should do to do the sort. So it's more metadata, let's say, and the second one to do the sort because we know the bucket. And to do the bucket, we do a sample of the data you should sort. So it's good, but there is better stuff. So we are working currently on the labs. For example, minute sort is really very good for performance. And also there is new stuff you can do through Tez, for example. So currently we don't leverage Tez, and that can also enhance our way to sort.
All right, so as Cedric mentioned, This is all a sandbox. It's a virtual machine. I'm sure you're familiar with the Hortonworks sandbox. Cloudera equally has one as well. You can download from the website. We basically built 2 flavors of this. So what you get is a Talend studio built on top of Hortonworks. It comes with a number of pre-canned demos. The one that we showed you today was Clickstream, but there's a number of other ones in there. We didn't talk at all about NoSQL. I guess this is a Hadoop conference, but NoSQL is very interesting as well. So there are a number of pre-canned examples of how we work with NoSQL. Again, code generation, same idea, open source. You kind of get the flavor for what we do.
We have Twitter example for sentiment analysis, for example, inside also.
And there's basically a step-by-step guide, as you might expect in there, and there's a video online as well to have a look at this. So we are basically showing this right downstairs in the cafe. It's kind of just over the parapet there. And there's a bunch of our guys basically there who can walk you through the sandbox if you want to have a look at it. So we're bang on time. Myself and Cedric are around all day. Happy to take any questions if you have them right now. Hopefully it wasn't too much of a demo of a vendor. We were asked to sort of step in last minute. We did take the Hortonworks open source demo and kind of give you a sense for what we do on top of the core Hadoop framework. So hopefully you found it useful, and happy to take any questions now or afterwards. Thanks. Maybe I can ask one question, a show of hands. Who is more interested in Spark versus Storm? This is a very interesting question. So Spark, Storm, it's almost equal. And don't care at all? Okay, all right, thanks for that.
You forced us to make a choice.
Yeah, exactly.
It was binary. Yeah, exactly. Yeah, there was no degrees. Yeah, hand up like this. I get you. Okay. What's that? It is absolutely, yeah. We have Spark components downstairs if you want to see them, and Storm is on the way. So yeah, no, it is. It's delivered this year. Yeah, yeah. Forced by our good friends at Hortonworks to basically not forced in cooperation. It's we're doing a lot of work with streaming right now and real-time big data. So that's kind of why we're very interested in Storm and Spark. So thanks again, everybody. Cheers.